Did it. Last day of Calc 1. You're here, you did it. Really great work on test 3. So I want to put that in the notes. Great work on test number 3. Test number 3 covered the very last of the material. So what's nice is that you've seen everything on a test now. And so in terms of review, I know this is a busy time for kind of wrapping up projects and whatever. So all I really want to do today is just go through question by question what to expect for the final. And then I have posted a practice final, which is, you know, similar to the actual final, just to give you an idea of what to expect. So there is a practice final, and I will say that don't feel pressured to get all your questions done or kind of to me today. I'm available, so I will be available for exam help pretty much anytime. Just let me know anytime except 1 till 4 on the Wednesday. Except 1 till 4 on April 21st, because then I have a pre-calculus exam. But besides that, just let me know and we can meet in Zoom. Just let me know. I changed my pen in here. It was supposed to help my writing get better, but I don't think it, I think it's worse, or it's just more obvious that it's really bad. Just let me know and we can meet in Zoom anytime. Right, so maybe once you've had a chance to actually run through the practice test, then I'm happy to meet anytime. And that includes the weekend. Weekends and daytime or kind of weekdays are all the same to me, so don't worry about that. And especially this time of year. Oh, and I did want to clarify about, I sent out a long announcement yesterday, sorry about that. I know no one likes reading long emails. But so what I've done, because not a lot of people have been keeping on top of the assignments. So if you have been, then that's really good. I don't want you to feel like it was all for naught. But what I've done is I've extended all the assignment due dates until April 21st at midnight. There is a 30% penalty, so the highest grade that you could possibly get is 70%. I think that's what makes it fair to anyone who's done it on time. I will say this, that any marks that were submitted on time will stay, but let's say you got you know, like 7 out of 10 on an assignment, and now you feel like, hey, I could probably go back and really conquer that assignment now because I know so much more, right? Then you can go back and those extra 3 marks, they would be subject to the 70% penalty. But what's 0.7 times 3? You could boost your mark by 2.1, putting you at 9.1 out of 10. That's pretty good because you had 7 out of 10 to begin with. So anyway, so it's for everyone to be able to boost your grades. So just the note, the 4.2, 4.3, 4.4, and 4.7 assignments are still due tonight. So if you want kind of full jackpot on those, you have to do them before midnight tonight. But then tomorrow morning, I'll extend the due dates for those as well with the penalty. So you've got a little bit of time to do those. So assignment 4.2, 4.3, 4.4, and 4.7 are due tonight. Okay. And then hopefully that kind of makes sense. If you're not sure, then let me know. But tomorrow morning, oops, I will set the due dates, the extended due dates to April 21st. So right up until midnight before our final. It's a lot of assignments. So due dates to April 21st at 11:59 with a 30% penalty. And I tried to explain it in the email. So I will say see announcement for details. So if you want to kind of boost your assignment grade, I can't remember how much our assignments are worth, but probably about 20. You've got the, how much are they worth? Oh. Let's see here. Log in. Yeah, 20%. So quite a bit. And then quizzes are 15. And then once I have your lab grade, the lab instructors send them to us once they have them all sorted. And then I'll put your lab grade in on Moodle as well. And so, but obviously I don't have those yet. So it's good. Okay, so let me know if the assignment situation is a little bit weird or if you're confused, but otherwise just use that time to maybe boost your assignment grade. Okay, let's talk about the final exam. I think that's all I wanted to mention. That's not final exam related. So the final exam outline, there are 23 questions, and I would advise you to try to keep your pace up, right? If you find that you're bogged down on a question for a really long time, maybe put it to the side for a little bit. And I'm still marking all your work, right? So it'll still be eligible for part marks, just kind of as I deem fit. So you'll have the full 3 hours to do it and to upload your work. So I think it's quite a bit of time. But question 1 is way back to limits. I've tried to keep it kind of in the order that things appeared. So we start in kind of chapter 2, limits, basically just limits. And then chapter 3, we introduced, well, how do we find derivatives, calculating derivatives. And then chapter 4, applications of derivatives, right, in terms of graphs and optimization and all that stuff, right? So, okay. Question 1, you're going to be given a graph to find limits. So that's a nice kind of easy start, or hopefully easy start. You've seen that before. Pretty much, I don't think there's anything here that you haven't seen before at some point on either a quiz or a previous test. So, or I know there isn't. So just kind of keep that in mind. You can go back to the tests or the quizzes. They'll make for a good review, or even the practice tests, the previous practice tests as well, right? So you're not just limited to the practice final that I've posted. But okay, so the first one, I'm going to give you a graph, and then you have to use it to find the limits. Fair enough. Then we're going to find an infinite limit, which means that the limit is going to infinity, right? And then we had to determine whether it was going to positive infinity or negative infinity, right? So it's one of these, the limit as x goes to a of f of x is going to either positive or negative infinity, right? It's a special way of not existing. So you have to determine whether it's going to be positive or negative. So, so far so good. Then I'm going to give you a piecewise function. And again, of course, you're going to have to find some limits and pick the right graph. You can use Desmos, right? Just to kind of make sure you're on the right track. It is piecewise, so you have to kind of imagine your pieces being put together in Desmos, unless you want to spend the time adjusting the x-axis, which I don't think you want to do, but I guess you can. So I'll say given a piecewise function, given a piecewise function, find limits, more limits, find limits and pick the graph. I've seen one of those, or we've seen those before. Question 4 and 5 are basically just going to be find the limit of this thing. And so question 4 and 5, find the limit. These, of course, are not going to be just plug in the values and make it work. You're going to have to make use of things like factoring, right? You can try factoring, you can try rationalizing. Those are our go-to things that we can use. What else could we use? I think those are our most common ones, right? So try factoring, or try rationalizing, because direct substitution is not going to work. Okay. In question 6, you guys got me on test 3. I thought you would be jumping for joy to use the L'Hopital's rule, but quite a few of you decided, no, I have the tools to find this limit without L'Hopital's rule. Fair enough, fair enough. I thought L'Hopital's rule was easier, but you guys were able to find the limit regardless. So I tried to pick one where you kind of have to use L'Hopital's rule, or at least that's the easiest thing to do. For question 6, I want you to use L'Hopital's rule, even though it has that thing. If there's a more simple way to do this, then use that. But here, I want you to use L'Hopital's rule. Oops. To find the limit. One thing, I know, yeah, so, and you guys were like, well, this is more elementary, so let's use that. Don't worry, that's totally fine. As long as you can find the limit, I'm happy. So, so that's really good. But you guys did more work than you had to. So here for question 6, I'm going to say just go ahead and you can just use L'Hopital's rule to find the limit. Remember, so one thing that I didn't see a lot of was I want to see the indeterminate form. So show the indeterminate form. it to justify using L'Hopital's rule, or maybe I'll just say LH rule. Okay, so I will say that I do want to see that indeterminate form just to say, hey, I'm justified in using this. Okay, so that's the only kind of mashup that I've done. I've put, yeah, the 0 over 0 or the infinity over infinity. You want to show that.
Yeah, in the test itself, it was, I think, negative infinity over infinity or something like that.
Yeah, I think it was in infinity 1 because it was a polynomial over a polynomial, right? So, yeah, and I think it was going to infinity. I can't remember actually, but I'm pretty sure. So, yeah, so just show that it's in the indeterminate form. Right? Cool. Yeah, so L'Hopital's rule is, of course, in chapter 4, but I lumped it in with the limits because I think that makes more sense. So, good. Question 7 is going to be with a discontinuity. So remember, discontinuities have to do with the limits. If the limit exists and is the same as the function at a point, then it is continuous. Otherwise, you have a discontinuity, right? And so discontinuity, remember, if the limit as x goes to a of f of x is not equal to f of a, right, then f of x is discontinuous at a. Then f of x is discontinuous at a. Okay. So you want to justify it by talking about the limits and also evaluating the function. Of course, the limit only exists if the left-hand limit equals the right-hand limit, right? And then they have to equal the actual function, which if you think about a discontinuity, right, you can kind of arrive at the definition from just thinking about what it means. And also, and pick the graph. Okay. Question 8 is the intermediate value theorem. Or the IVT. Okay. Remember, the intermediate value theorem says that, okay, if you are able to pick a point where the input gives you a negative value and then you're able to pick a point where the input gives you a positive value or vice versa, right? At some point, the intermediate value theorem says that at some point this thing equals 0, and it could have more than one of those, but we're just identifying if we have any roots. Okay, so if f of a is less than or equal to, or I'm going to say less than 0, and which is less than f of b, right? Then by the intermediate value theorem, and I'm paraphrasing here, but then by the intermediate value theorem, f of x equals 0 at some point, potentially more, right? It could have waved across. It has to end up on the other side, but at some points, x equals c, right? So some point, random point c. We don't need to find that point. We just need to say that, hey, there is a root, right? This is really saying that f has a root, right? One or more roots. Okay. question 9. Is going to be another limit. It's going to be an infinite limit or a limit to infinity. I always mix those up. An infinite limit is when the limit goes to infinity, and a limit at infinity is what I want. So a limit as x goes to plus or minus infinity involving a square root, right? And so we've seen that before. What's important is that if you have a negative infinity, right, then x is going to be negative, and so you need to adjust that when you bring it into the square root, right? So you need to keep track of that. So a limit as x goes to plus or minus infinity involving a square root. Okay. Okay. Do you remember what we did? Right, we had to divide. Oh yeah, and it was a limit as x goes to infinity on the test, because this is the trick that everyone thought was, oh, that's just easier. I'm like, hey, good for you guys. Divide by the highest power of x in the denominator. And then you use the fact that that the limit as x goes to infinity of 1 over x to the n, or something, or sorry, that should be an n. It's going to go to 0, right? If x is going to plus or minus infinity, you're dividing some constant or even some lower power of x. Those will cancel, right? So you can have a constant over an x to the power of something, even if it's just 1, it kind of goes off to 0, and then that's how you're able to whittle it down. Okay. 10, you have to use the limit definition of the derivative. It is going to be a really easy derivative, so you can check your work just using, I think it's even don't want to say something. It could be as easy as a polynomial, right? And so I might have thrown a fraction in there. I can't remember. But you need to use the limit definition of the derivative to find the derivative. What is it? The limit as x goes, or sorry, as h goes to 0 of f of x plus h minus f of x over h. Right, so you have to construct that difference quotient, and then there's going to be a lot of fractions involved, right? So you have to take your common denominators, you need to remember all those, and then eventually, right, if you've done things correctly, this h, which is making a mess, right, because h is going to 0, so I can't let this h go to 0 yet. Eventually this h will cancel, and then you're going to have the derivative of f of x. So you have to use the limit definition. 11. Given some distance function s of t, you're going to have to find v of t and a of t, so the velocity and the acceleration. So find v of t, which remember is just s prime of t, and a of t, which is s double prime of t, or the derivative of the velocity if you prefer. Right? And then use the derivatives to evaluate the function at some points. So for example, what's the velocity at 9 seconds, right? So, and then use the derivatives to find values. I'll put an example here. Find the velocity at 9 seconds, right? Something like that. That's v of 9. So you evaluate the first derivative at t equals 9. Right? Okay. 12. Now we're into kind of derivatives, and it will feel weird to have some of these kind of easier derivative questions now, because we've used derivatives in different ways, and we've seen some really hard derivatives, right? And so I want you to find the equation of a tangent line at a given point. Fair enough, right? Use x naught, y naught, for example. If that's the point, then you have y minus y naught equals f prime of x times x minus x naught. And then you can rearrange that to find the equation of the tangent line, right? Because here's the slope, right? And then you have your point that you've been given. 13, 14, and 15 would be one question typically, but of course, WebAssign doesn't do that. So it is kind of increasing the number of questions, but 13, 14, and 15 are all just find derivatives, right? That could be involving the product rule, the quotient rule, the chain rule, or some combination of those, right? What other rules do we have? That's pretty much it, right? And so there are going to be some derivatives. So just plain old calculate derivatives, right? Could be product rule, quotient rule, chain rule. Am I missing any? I don't know. Those are kind of the ones
Those are the only ones that I remember are being like complicated, because pluses and minuses are
you got to keep
very
those straight.
straightforward. You got to keep them straight, but they're very straightforward.
Yeah, as soon as you see a polynomial now, it's like, yeah, party time. Just knock them all down.
It doesn't even get the yay party time. It's like, oh yeah, ding, done.
I know, aren't they so fun now? Yeah. Whenever I have to do, because some of the courses that I teach, we need to find the derivative of a polynomial. And I'm like, okay, guys, we're going to do some calculus. And everyone's like, no way, I'm never doing calculus. And I'm like, see, you just give it like a bump from the right. And everyone's like, okay, I think I get it. I'm like, that's not really calculus, though. Calculus is harder than that. But yeah, you just gotta give it like a bump from the right. Anyways, pretty fun. So just make sure, and it can be a combination of the product rule, the quotient rule, or the chain rule. So you want to kind of practice those a little bit. But at this point, from what I've seen, you guys are really good at finding derivatives, so that's good. I'm happy with that. Implicit differentiation. What we had to do, right? We had to, we've got some function and there's no easy way to solve for y. And so what happens is you kind of treat y's as if they're x's, but when you take the derivative with a y, you tack on a y prime or a dy dx if you prefer on that term, right? And then you solve for dy dx. So I don't know how to write that out. It's kind of unofficial. Find derivatives of x normally any derivative involving y is also found normally, and by that I mean usually a power rule, right? Just kind of bring that power down. Is also found normally, but also multiplied by y prime or dy dx if you guys have come around to differential operators, and then solve for y prime. Right, so then you rearrange it and then solve for y prime. There's a logarithmic differentiation, which is kind of fun as long as you remember your log laws, right? So 17 is going to be on logarithmic differentiation. Right? Because the fun part about the log of x is that the derivative is just 1 over x. So even if you're involving the chain rule, then it becomes quite a bit easier, right? So take the log of both sides here. Take the log. Usually I'll use the natural log of both sides. Then differentiate. Right, and dx of the log of x is just 1 over x. And that's what makes it so much easier to work with, right? Also because multiplication becomes addition when you apply the logs, right? So it kind of breaks things up nicely. Next question is related rates, which can be a little bit tricky sometimes, but I have been really impressed with you guys for doing them. So related rates, and I'm not going to do anything too crazy, right? In fact, I tried to keep it kind of, I hate to say easy, nothing's easy, but kind of reasonable. I think it's even a Pythagorean theorem one where we have to use a triangle, I'm pretty sure. But related rates, right? So we're given some rates and we want to find some unknown rate, which means that we have to find some function that we can kind of link all these things, and then we take the derivative of that function, and then we're able to plug in our unknown or our known values and solve for the unknown rate, right? I feel like that's all of related rates. So I don't have a blurb for that. What could I say for the related rates blurb? Nah, you guys know what to do. 19 is on linearization. It's kind of that weird last section in chapter 3 where if you have to, it's usually involving square roots, right? It's an approximation for square roots typically, because division is just a lot easier to do if you're working entirely by hand. So go back, I don't know, hundreds of years here. Then if you're doing these calculations by hand, then division is a lot easier than taking the square root, for example, or any root. And so the linearization lets you do that. And we've seen some, right, and we said that L of x is approximately, now I have to kind of rearrange it in my head, f of a, I think, minus
Plus
f prime of a.
F prime a x minus a.
Thank you. I was going from the point slope form. I was trying to move things around. Didn't work. So thank you. Okay, and so do a linearization and use it to evaluate some functions. Approximate, right? You don't just want to use your calculator. You want to use your linearization. 20. Home stretch here, there are only 23 questions, right? So 20 is a maximum and a min problem on a closed interval. We know what to do there. You have to find your critical numbers, and then you have to look at your endpoints as well as your critical numbers, and then evaluate the function at those values of x, and then you're able to identify your max and your min, right? 21, the mean value theorem. Mean value theorem. Mean value theorem is f prime of c is equal to f of b minus f of a over b minus a at some point in an interval a, b, right? Which says that the slope of the secant line connecting the two endpoints, at some point in here, the slope of the tangent line is equal to the slope of the secant line, right? And so meaning they're parallel. And you have to use it to find C. So find the C that makes that true. Again, you've done this before, so it's not anything crazy. (22) derivatives and graphs. This is, again, just like we saw on test 3, right? You have to look at intervals of increase or decrease. Which, the dog's really mad. I don't know if you can hear her growling. Anyways, so you have to find the intervals of increase or decreasing, which means finding the critical numbers and then using maybe some test points in between those critical numbers to figure out if the derivative is positive or negative. And then I want you to find your, I think that's it, the inflection point. So potentially, oops, inflection points. So the inflection point, we have to find where the second derivative is equal to 0. So basically sort of like a critical number, but for the second derivative. And then if the second derivative is positive, it's concave up. And if it's negative, it's concave down. Again, all things that you've already seen and also kind of recently. Good. And then the last question is an optimization question where we have to figure out some sort of equation, and then to optimize that equation, right, we have to find the derivative, set it equal to 0, because that is an optimal value, whether that's a maximum or a minimum. We don't really spend any time thinking about, but we should, but we don't really. We just find the derivative, set it equal to 0. Often that involves solving for, so we're given some information so that we can solve for one of the variables so that we have the derivative in terms of just one variable. And then we can figure out what the optimized value is, which you did great on the test. So, and that's it. I shouldn't say that's it. That's a lot, but hopefully nothing is feeling too scary, right? But like I said, if you do have any questions, I'm happy to go through them now, but I know it's a busy time, so if you've got other stuff you need to do, that's totally fine. But I do want to say thank you for a great term, and you guys have been really great. And yeah. Nice.
Thank you. It's been really fun. So. And yeah, I've got some stuff that's got due dates of 4 p.m. today. So yeah.
No worries.